Hi you guys, this is Ms. Place. I'm going to be going through some examples of unit conversions, or sometimes we call this unit analysis problem solving. We've done some of these questions in class, and so if you are seeing me solve something that you already know how to do, you can fast forward. But the way I'd suggest you use this video is to try each problem yourself and then pause it. Well, pause it to try each problem, and then keep playing the video to see if you got that problem right, and then pause it again and try the next one and see if you are showing all your units and getting to the right answer with the right number of significant digits. So at the top of this sheet here we have a table that has some conversion factors between different kinds of metric and SI units. So we might be using some of these. And sometimes we'll be using conversion factors that are just given in a problem and using those. So you can use tables from your textbook for problems like this, or sometimes you'll just have all the information you need right there in a problem. So we're going to jump right in with this first question, which is asking us, it says a pencil is 19.1 centimeters long. We want to know what this is in millimeters. And I'm going to give you an equality here, although you probably already know this. And that equality is that 1 centimeter is the same thing as 10 millimeters. So that's sort of like the equalities that you see in that table. And we can write those as unit conversion factors by writing them as fractions. But for right now, we're going to solve this problem. And the way I want you to solve these problems is to always start by writing what you know, which is writing what is given in the problem. So I'm going to write down that number, 19.1 centimeters. And I want to write the whole number, and I want to write its unit. It's really important that you always have the unit next to everything. So I've written what I know. Now I'm going to multiply this by a unit conversion factor. And the unit conversion factor I want is the one that would cancel out centimeters. So I want to have centimeters on the bottom, and would give me millimeters. So putting millimeters on the top. So you don't have to write these words in that I'm about to write in orange, but essentially whenever you're doing unit analysis, you're putting what you want to cancel on the opposite side from where it appears in your original number. So because centimeters was on the top, I'm putting what I want to cancel on the bottom. And because I want to get millimeters, that's going to go on the top. That's the unit that I want in my answer. Okay, so that's why I'm choosing to put those there. So now I'm going to look at my equality. My equality says that there's 1 centimeter for every 10 millimeters. So the number 1 goes next to centimeters, and the number 10 goes next to millimeters. So 1 centimeter for every 10 millimeters. So what this does is it lets me cancel out some of the units. Centimeters are on the top, and they're also on the bottom, so they cancel out. Centimeters divided by centimeters, it goes away. So now I can see that my unit is going to be millimeters. So to do this math, it's going to be 19.1 times 10. It's also divided by 1 on the bottom there, but that's not going to change the value of my answer. So 19.1 times 10 is 191. And because the millimeters didn't get crossed out, I write that as my unit. So it's 191 millimeters long. Whenever I get to the end of a question, I want to also check that I have the right number of significant digits or significant figures. So I have to go back and look at all the numbers that went into my problem. So 19.1 went into my problem. That has 3 sig figs. The 10 and the 1 also went into my unit conversion, but this conversion factor is from a definition. And so it's something that we consider to be an exact number. So it has infinite sig figs. So you want to ask yourself, which of these has the smaller number of sig figs? And it's the 19.1 centimeters, which had 3 sig figs. So my answer is also allowed to have 3 sig figs, because I have to round to the smallest number of sig figs. So that also has 3 sig figs. So that looks good. You don't have to write in the number of sig figs in your answer. The only things you need to show when you're doing problem solving are everything that you see here in blue right? The units and the numbers and the operations. And then you should also show how your units are canceling. So those things that you see in red there, where I've crossed out the centimeters, you should show that also. Those other notes I wrote in there are just so you understand what I'm doing. So now would be a good time to pause this video and try the next problem on your own. Okay, so I'm going to do problem 1b. So what is the length of the same pencil in inches? So I'm writing down my original number, again, 19.1 centimeters. And I want to cancel out centimeters, so that's going to go on the bottom. I want to get inches, so that's going to go on the top. And I look at my equality, which is written right here in the problem. There are 2.54 centimeters in every 1 inch. So my centimeters are going to cancel out, so I can cross those out. And I'm going to get a value that is in inches. So because the 2.54 is on the bottom of a fraction, I'm going to be dividing by it. So on my calculator, you're going to see me entering 19.1 divided by 2.54. And I get that number, 7.519685039, but I want to round it appropriately. And I have 3 significant figures here. Even though this actually happens to be an exact conversion factor, but normally when we're going between English and metric units, it wouldn't be. So I think it's good to get in the habit of looking at sig figs for your unit conversion factor. But I can have 3 sig figs in my answer again here because 19.1 had 3 sig figs. So I'm going to say it's 7.5, and then I see that 1 has a 9 next to it, so I'm going to round up to 7.52, and I say inches. Right? So that is my correct answer, and it also has 1, 2, 3 significant digits. All right, we're going to go on to the next page, and this is where we're going to do unit conversions that require more steps. So again, you can pause this and try this problem on your own if you like. So a carton contains 1.0 quarts of milk. So I'm going to write that down. I'm always going to start by writing what I know. How many cubic centimeters of milk are inside? And I've got 2 equalities here. And that first one that I see, because I want to cancel out quarts, I'm going to put quarts on the bottom. And I have a conversion factor between quarts and milliliters. So I'm going to use those numbers that I see in the equality. 946.4 milliliters are in 1 quart. And that lets me cancel out the quarts. Quarts on the top, quarts on the bottom, they cancel out. So now I have milliliters. I want to go to centimeters cubed, so I'm going to use that second equality that I've been given to cancel out milliliters, so they go on the bottom, and get cubic centimeters. They happen to be the same unit. A cubic centimeter is also called a cc. We use that in medicine, and there's 1 cc for every 1 milliliter. That's an exact number because that's the definition of a milliliter, is that it's a cubic centimeter. So that lets me cancel out another unit. The milliliters cancel, and I get centimeters cubed. So I need to do my math. So on the top here, I have the 1.0 quarts. I'm multiplying that by 946.4 milliliters. Then I'd also multiply it by 1. I don't need to include that last step because that's not going to change my answer. And I get that value. That would also be divided by 1 times 1 on the bottom. But again, that doesn't matter to the value of our answer. So we're just doing 1 times 946.4. When I decide what to write down, though, I have to think about significant figures again. That 1 quart, that's a measured value, right? That's the quantity of milk they say they've put in that carton, and it's not exact, right? That has 2 significant figures. This next conversion factor, 946.4, that has 4 significant figures. So we have something with 2 sig figs and something with 4 sig figs. And then all of this right here, this is an exact number, and so is the 1 quart that we see on the bottom of the 946.4. So we need to round to whatever is the smallest number of sig figs. So we want to have 2 significant figures. So instead of saying 946.4, I'm going to say 950 centimeters cubed. And that's my answer, and it has two significant figures as it should. Okay, so again, pause this. You may want to try the next one on your own. This one is more complicated because you have to convert all the way to microliters. So it says convert the volume you found in A to microliters. So I'm going to write down my answer from A. That's 950 cubic centimeters. And I need to get to microliters. Now, I don't see any information on this sheet that lets me get straight from centimeters cubed to microliters. But I could get from centimeters cubed back to milliliters again. I do know that conversion factor because that's given in the previous problem, that a cubic centimeter is actually the same thing as a milliliter. So that helps me part of the way down my road, is to get into milliliters. So I'm going to go take a look back at the table that I have and see if I can figure out what I can convert milliliters into. So I'm going to go look at this table of conversion factors. So I'm scrolling back up and I'm looking, well, what is a milliliter? So here's milli. And over here, it says that a millisecond is 1 times 10 to the negative third seconds, or you could say that a second is 1,000 milliseconds. So I can use this for any base unit that I want. It doesn't have to be seconds. So instead of that equality, 1 second equals 1 times 10 to the third milliseconds, I could say 1 liter equals 1 times 10 to the third milliliters. Right, so that's an equality, or you could say there's 1,000 milliliters in a liter. But I'm looking at this table to get that conversion factor. So let's keep that in mind. There's 1 liter in 1,000 milliliters. So I'm going to put 1,000 next to the milliliters. And I'm going to put 1 liter up here. And the reason I'm doing that is it lets me cancel out milliliters. And it's let me convert into the base unit. The base unit is the one that doesn't have any prefix in front of it. It's just liters. And I'm doing that because if I know if I can get into the base unit, I can get into whatever other unit I want in the metric system. So I'm in liters. I want to go to microliters. So because liters is on the top, I'm now going to put liters on the bottom and microliters on the top. So this is going to be my last step, is getting from liters into microliters. So again, I'm going back up to that table and I'm looking for what micro means. Like, what is the conversion factor for micro? Right, here's micro. We have these equalities over here. And because I'm interested in liters, right, 1 base unit liter, I see 1 base unit gram equals 1 times 10 to the 6th micrograms. So I could also say 1 liter equals 1 times 10 to the 6th microliters, right, microliters. So I'm going to use that equality back down here. So 1 times 10 to the 6th, that's a million, right? There are a million microliters in a liter. And that lets me cancel out my liters. And so what I've done is I've converted from centimeters cubed into milliliters, from milliliters into liters, and then from liters into microliters. And yes, you could make this shorter by eliminating all those ones and just using the conversion factor that there are a million microliters for every 1,000 milliliters. You're absolutely welcome to do that if that makes sense to you. I'm going to go ahead and do my math, right? So what I'm doing is I'm going to be multiplying everything that is on the top of my fraction. Right, that's essentially like 950 times 1 times 1 times 1 times 10 to the 6th. Then I'm going to be dividing by everything that's on the bottom of the fraction, which is 1 times 1,000 times 1. Right, so you can look at it like that, like you're multiplying fractions. So I'm going back to my calculator here. So I've got 950. And I could say times 1, but we know that's not going to change anything. So I'm going to go right ahead and multiply that by 1. Second function e, that means times 10 to the 6th. So that's everything on the top. I'm going to press enter. I've got my result. I'm going to divide by what's on the bottom, which is 1 times 1,000 times 1. So that's really 1,000, or 1 times 10 to the third. And I get this value here, which is 950,000. And I use the 1 unit that hasn't canceled out yet, and that is microliter. Microliter. And I can leave it like that, right? It would be perfectly fine for me to leave my answer like that because I've got two significant figures here. And then all of these conversions are all exact because they all came from that table of metric conversions. So they have infinite sig figs. So my answer having 2 sig figs is correct. Because it's a large number, some of you may wish to put it in scientific notation, and that would be 9.5 times 10 to the 5th microliters. Okay, so that is our answer to that longer problem. The next two are shorter, so if you want to try them on your own, again, pause this video and go ahead and try them on your own. So question C, the carton says it contains 2% milk, which means that the milk contains 2% milk fat by volume. What's the volume of milk fat inside the carton? So they haven't given me any units that they particularly want here. So I could use anything that I want, really. I'll just go ahead and use that original volume back up there that says 1 quart. But could you use 950 centimeters cubed? You could, right? You could totally use that. So that's a quart of milk. So a percent, right? A percent is a part of 100. So I'm going to take that 1 quart and I'm going to say that it's 2 out of 100 parts fat, right? 2 out of 100 parts milk fat. So I'm just multiplying this essentially by 2% in the decimal form. So 1 quart times 2 over 100 is going to give me 0.02. And see how the quarts didn't cancel out? We were just finding a small fraction of a quart, a small percent of a quart. And so it's just 0.02 quarts. And the reason I'm picking only 1 sig fig here is I think when they label milk, right, this is 2 sig figs here, when they say it's 2% milk, I don't think that's an exact number. I don't think they're able to hit that right on. So we're going to call that a measured number and say that our answer should therefore only have 1 sig fig, so 0.02 quarts. That's how you use a percent as a unit conversion. So if you didn't pause this video before and try your own, do that for this next one because it's exactly the same problem except for 4% milk. So for 4% milk, I'll take that same 1 quart, and I know that there are 4 parts out of every 100 that are milk fat, and so I'm going to say, well, that is 0.04 quarts out of that whole bottle is milk fat. And again, I'm going with 1 significant digit because I'm assuming that 4% is not something that any milk company knows exactly or any dairy farmer knows exactly. So that's how you use those in unit conversions, just a certain number of parts over 100. All right, so let's go on to compound unit conversions. Compound units are ones that have 2 parts, and a really common example would be like the velocity of your car or the number of miles per hour you're going in your car, because there's miles and there's hours. Another common example is given here in number 3, and this is a gas mileage. So I drive a hybrid car, and so it actually gets really great gas mileage. It gets 53.2 miles per gallon. And in this problem, I want to find my car's fuel efficiency in kilometers per liter instead. So I'm going to write down what I know. So that's how you always want to start these problems, is writing down what you know. So I have 53.2 miles per gallon. And don't just write MPG like you might if you were actually writing down your car's gas mileage. You want to write down the actual units, right? So that's miles on the top and gallons on the bottom, because that's going to help you do the unit conversions correctly. So we have units of miles on the top of the fraction, units of gallons on the bottom. So I want to get into kilometers per liter. So I'm actually going to have to convert both of these units, and I'll do it one at a time. It doesn't matter what order you go in, right? You can go in whatever order you want. So since I see miles are there on the top, I'm going to go ahead and convert my miles first. Right, so I'm going to put miles on the bottom, and I want to convert my miles into kilometers. And I've been told in the problem, this equality, that a kilometer is 0.62137 miles. So 1 kilometer on the top, 0.62137 miles on the bottom. So that lets me cancel out my miles. So I'm halfway there. because the miles canceled. And right now, if I solved, I'd have my answer in kilometers per gallon. So we're going to keep going because we want to now work on the gallons. So the gallons are on the bottom of the fraction at the beginning. They're on the bottom. So if I want to cancel them, I have to go on the top, right? They have to be opposite if they're going to cancel. So that's gallons, and I want to get liters instead. And again, I've been given an equality over here. There's 1 gallon and 3.7854 liters. Okay, so the next thing that cancels out would be gallons. I'm just going to use a different color here so you can see that the gallons, even though they're way far apart, gallons on the bottom, gallons on the top, they still cancel. It doesn't matter how far apart they are in the problem. They still go away because it's all one big multiplication. So then if I check, I see I've got kilometers on the top and liters on the bottom. And that's exactly what I want, right? I want kilometers per liter. So I can go ahead and solve my problem now. So on my calculator, so I've got 53.2. And I want to divide that by 0.62137. That's my first operation. And then I want to divide it also by 3.7854. And yet you could use parentheses and do that all in one step. But I get this number, 22.61775904. And so that, of course, makes me think, oh, I have to think about how many significant figures I can have in my answer. So let's count up what we've got. This one has 3 sig figs. This is a conversion between an English unit and a metric unit, so it is not an exact number. This one has 5 sig figs. This factor also has 5 sig figs. Again, it's not exact because it's going between a metric and an English unit. So looking at all these, my smallest number of sig figs is 3. So I need to round my answer to 3 sig figs. So I'm going to say 22.6. And that is kilometers per liter. And that's my answer, and it has 3 significant figures, and I've written the units next to it, and so everything looks perfect. All right, so here's our last problem, and I'm calling this a challenge problem because you're using a unit conversion that is given to you in the problem, but it's sort of disguised as a density. So take a look at this, give it a try, pause the video, and then come back and see if you got the right answer. Okay, so I'm going to start out in this problem by writing down what I know, and that is the mass of the atmosphere. Right, so what we're trying to do here is find the volume in megaliters of the Earth's atmosphere. And I'm starting with its mass, 5.1480. That has 5 sig figs, times 10 to the 18th kilograms. And I want to get to megaliters. So I have to ask myself first, okay, well, I've got kilograms here, so even if I can see no clear way to get to megaliters, I can at least say to myself, well, I need to get rid of kilograms, right? I need to get rid of kilograms. And so that's going to go on the bottom. And something I can always convert any unit into is its base unit. So I could go from kilograms to grams. And if you don't already know that conversion factor, you might know it from other classes or just from life, but you can go back up here and check on what kilo means, right? Kilo, right? We've got kilometers and meters over here, but I could say that 1 kilogram equals 1,000 grams, 1 times 10 to the 3rd grams. So that's the conversion factor I'm going to use in my problem to get into that base unit. So 1 times 10 to the 3rd grams are in a kilogram. So that is great because it gets me out of kilograms and into a base unit. So now I have grams. So what could I convert from grams into? And again, I'm trying to head for megaliters. So I want to get from a unit of mass into a unit of volume. And if you notice those two things I just said, mass and volume are related to each other by density. And we have this nice value here for the density of air. It's 0.001225 grams per cubic centimeter. So this is the tricky part of this question, is I'm going to use that as a conversion factor, right? Because I want to cancel out grams and I want to get volume. So I'm putting grams on the bottom, centimeters cubed on the top. And that number is what I can write in there. There are 0.001225 grams in every 1 centimeter cubed. That density is being used as a unit conversion factor. So that lets me get rid of the grams. And now I have centimeters cubed. And that's awesome because it's a unit of volume. So now I can head for megaliters, right? Megaliters. So I want to get rid of centimeters cubed and I want to somehow get to megaliters. Now I remember from a previous problem that in every 1 centimeter cubed, there's 1 milliliter. And so that would let me cancel out my milliliters. Sorry, cancel out my centimeters cubed. Next, I want to cancel out milliliters. So I also remember from a previous problem that there are 1,000 milliliters in every liter. And so that would get rid of my milliliters, right? And I'm so close. I'm so close to the answer here. So I'm in the base unit of liters for volume. And now I know I can get from a base unit, which is liters, into any other prefix unit. And we want megaliters. So because I don't remember what a megaliter is, I'm going back up. I'm checking on my table. I'm looking for mega. And here it is, mega, right? Those are our equalities. So the unit conversion I want is that 1 megaliter equals 1 times 10 to the 6th. That's 1,000,000 liters, right? 1,000,000 liters are in a megaliter. So let's go back down and put our last unit conversion value in there. So in 1 megaliter, there's 1 times 10 to the 6th liters. All right, that was a super long problem, but I think we got it now. So, because our liters will cancel out and we'll end up with megaliters. So I'm going to write my answer down here. But first I have to do all my math. So I'm going to put in that original mass. In scientific notation, I go 5.1480. Second function, e, which means times 10 to the 18th. I'm going to multiply it by everything that's on the top, and pretty much everything on the top is a 1 except for the 1 times 10 to the 3rd. So that's what I get when I multiply everything that's on the top. Now I'm going to divide by everything that's on the bottom. I'll go ahead and use parentheses here. So I've got the 0.001225, and I have the 1,000. Actually, we could have just canceled it out, couldn't we? Right? Because we'd already multiplied by 1,000, but I didn't notice. So we're going to keep going. And then times 1 times 10 to the 6th. I'm going to close my parentheses and hit enter. So we get a number that is in scientific notation, and it's times 10 to the power of 15. So before we write down our answer, let's go back and examine our significant figures. So our original number had 1, 2, 3, 4, 5. We had an exact conversion factor, and then this density had 1, 2, 3, 4. And then we had a bunch of other exact conversion factors. So we're choosing between 5 sig figs and 4 sig figs. And because 4 is the lesser number, we're going to go with rounding to 4 sig figs. So I'm going to say 4.202 times 10 to the 15th, and then look for the one unit that hasn't canceled, and that is megaliters. And that is my answer to the challenge problem. All right, so I hope that helped, and you can find these notes also in the class notebook if you just want the written answers. Thanks, you guys. Bye-bye.